Hello everyone, this is Mr. O'Leary with another mole conversions practice. In the last video we talked about how 1 mole, 1 dozen is equal to 12, and we massed out a dozen of grapes or bananas and we converted them between dozen to grams to number of, or from grams to number of, but we had to go through the dozen. And I talked about how it's the same thing going from 1 mole to 6.02 times 10 to the 23rd, or going from 1 mole to the molar mass in grams, where we find that on the periodic table. And I showed you on the periodic table, if we're talking about carbon, that'd be 12.011, boron would be 10.81, hydrogen 1.008. So we need to know the molar mass. So if we, just to show what we're talking about, just to explain it a little better, if we had 1 mole of lead, I'm sorry, that's PB, not PD. PB, right? So we would multiply that. What do we have to multiply that? PB, which is a 207.2, is the average atomic mass, which is 207.2. So 1 mole of PB equals, has an average atomic mass or a molar mass of 207.2. So 207.2 grams. So now we want to get rid of moles, so we have to put mole in the denominator. And we want to go to grams, so we don't know how many grams it is, so grams. So 1 mole of lead has 207.2 grams. And that would equal, well, first we're going to get rid of moles. Let me change. Oh, that's a weird one. Get rid of moles. So that would equal 207.2 grams of PB. And that's how we can go from moles to grams. Now, if I had 1 mole of lead, I can multiply that by, I want to get rid of moles, so they have to know the denominator. If I want to know how many of them there are, then I would have to do atoms. So we'd have atoms. And we know there are 6.02 times 10 to the 23rd atoms in 1 mole of anything. So we can cross out mole, and we are left with 6.02 times 10 to the 23rd atoms of lead. And that's our answer. So now, for some reason, students get pretty, I don't want to say freaked out, but they get pretty confused when we want to go from all the way over from mass in grams to lead. And this just showed you we can go moles. If I want to go from grams to number, I just have a gram of hydrogen is going to have a different number of atoms than a gram of hydrogen. So this is a great way to do it. Just practice. Let's practice some more. What did that pop up? Okay. So if we were to scroll down, and again, I would write this at the top. So we have 1 mole is equal to 6.02 times 10 to the 23rd of something, and that is equal to the molar mass in grams. So let's say I had 151 grams of lead, PB, and I wanted to know how many atoms that is. So if we're getting rid of grams goes in the denominator, and we want atoms goes in the numerator, so we're going to have atoms. Right? No, we can't go directly to atoms. We have to go through the mole. So we'd have to go from here to the mole, and then we'd have to multiply it again. That is really ugly looking times. So we're going to do that again, and then we have this, we have to go in the denominator, get rid of it, moles, and we want atoms in the numerator. So what we can do is, let me erase this out for now. So then we can put in our numbers. So we have 1 mole of lead is equal to, I know we just looked it up, let's look again, is 207.2 grams. So 207.2 grams. And then 1 mole of lead has what? 6.02 times 10 to the 23rd atoms. So from here, just to know, so we know our conversions are appropriate. We have grams cancel, we have moles cancel with moles. So then we are left with atoms. So what we would have is we'd have 151. So here we have 151 times 1 times 6.02 times 10 to the 23rd divided by, so I'm just going to equal that, divided by 207.2. So what we're left with is, oops, sorry guys, 4.3871, and if I had 3 sig figs, 1, 2, 3 sig figs, that's 4.39 times 10 to the 23rd. So we have 4.39, 10 to the 23rd. Atoms of lead. So in 151 grams of lead, there are 4.39 times 10 to the 23rd atoms of lead. Now, we could do the same thing. We could go through the mole and we could say I have a 0.37 grams of, let's say, hydrogen. Now I want to know a number. I want to know a number of hydrogen atoms. So from here, I need to go through the mole. So I put grams in the denominator. I'm going to need moles in the numerator. I'm going to multiply that. I have mole in the numerator over here, so I got to put mole in the denominator. So then I would have to go to atoms. So 1 mole has how many grams of hydrogen? So we look here, it's 1.008. So 1.008. And then 1 mole has how many atoms? 6.02 times 10 to the 23rd. And that's a horrible 10. 10 to the 23rd. So again, if we erase this out, we can see that it's 0.37. So where's my mouse? 0.37 times 6.02 times 10 to the 23rd divided by 1.008. And that's a very large, it is a very large number, but it's got a bunch going on here. So we have 2 decimal places, so we go to 2 decimal places, so it'd be 2.2 times 10 to the 23rd. So it would be 2.2 times 10 to the 23rd atoms of hydrogen. That's my answer. Which is less than a mole, and it's obviously less than a mole. It's about 1/3 of the mole, and that's about 1/3 of the 6.02 times 10 to the 23rd. So again, easily to go through. So let's go through and say I have, let's go the opposite way. Let's say I had 300. Let's make a ridiculously small number. I had 300 atoms of hydrogen. And I want to know how many moles I have. So if I'm here, I got to take and I got to multiply this by, I got to get rid of atoms. And I need to go to the mole. Always have to go through the mole. And then once I have atoms, I got rid of atoms. Now I need to get rid of moles. I have moles, and I want to get to, I'm sorry. We're not going to go to moles. We're going to go to grams. Sorry, I said moles, didn't I? Somebody should have corrected me, although you're not here. All right, so we're mole, and we're going to go to grams. So 1 mole is always equal to 6.02 times 10 to the 23rd atoms or molecules or whatever you're talking about. And 1 mole of hydrogen has how many grams? And we just looked on the periodic table a second ago, and it was 1.008. So we have 1.008 grams. And again, we just check our units, do a little dimensional analysis, get rid of atoms, get rid of atoms, get rid of mole, get rid of mole, and we are left with 300 times 1.008. We can put the 1 in there, but it's just y. Anything times 1 is itself. So divided by 6.02 times 10 to the 23rd. That is equal to, let's make this 3 sig figs. So we'll go through here. Let's 300 of them. Let's make it 3 sig figs. So 1, 2, 3, 5.02 times 10 to the negative 22nd. So 5.02 times 10 to the negative 22nd. So again, how does this work? It's 5.02 times 10 to the negative 32nd. It's 1 to negative 22nd, sorry. And we keep going 27 places, 22 places. I keep messing that up, sorry. So that's a bunch of zeros leading. It's a very, very, very small number. And you can see, because if I have 300, it's 300 of them. And I know that 6.02 times 10 to the 23rd, that's going to show it's going to be definitely a very small number. So I'm hoping that, well, let's do another one. Let's do another one. So if I were to have, let's say 1.0 times 10 to the 30th atoms. Let me write that again. Sorry, guys. 1.0 times 10 to the 30 atoms of helium, let's say. So, and I want to know how many grams that is. So I'll put grams over here. How many grams? So if I have atoms, I need to go through the mole. So we have here, get rid of atoms. And we want to go through to the mole. And we multiply this out. And then we're going to get rid of mole. And we're going to go to grams. So we know 1 mole has how many atoms? 6.02 times 10 to the 23rd. And 1 mole of helium has how many grams? When we look at the periodic table, it would be 4.0026. So 4.0026. So if I take out my trusty calculator, we have 1 times 10 to the 30th times 4.0026 divided by 6.02 times 10 to the 23rd. And we're looking at, my mouse stopped moving. I need to really fix that. So we're looking at a rather large number of, we have 2 sig figs here, so let's go to 6. So we have, so what's that? Thousands, millions, so 6.5 million. So let's say 6.5 million. We can do it over here. Equals 6.5 million, or 6,500,000 atoms of helium. Now, when you evaluate this, what you need to do is you need to say, is that reasonable? So if I have 1.0 times 10 to the 23rd atoms, grams. Grams. So let's fix this. And I have it right here. See, that's why we use dimensional analysis. We look at our answer to see, does this make sense? Is it going to make sense? And that's exactly what I just did. And I noticed it didn't make sense. So 6,500,000 grams of helium. Now, no, it does not make sense. It's 6,600,000. I messed it up again. So we have 6,500,000 grams. Well, if we have 1 times 10 to the 30th atoms, 1 of them is equal to 4 grams. So, yeah, it makes sense. It makes sense. So let's practice some of these. I'll put up a video for you guys to practice them. And then we will move on to limiting reagents after we practice this a couple of times. Have a good day, everybody. Stay safe, and goodbye.